Welcome to the presentation. I am Anita MC, Selection Grade Lecturer, E&E Department, PISSJ Government Polytechnic, Bhadravati. Today, I will be covering the first topic of Unit 2, Digital Principles of the subject Digital Electronics. The course outcome is Appraise Digital Principles and Number System Conversion. It includes introduction to digital system, definitions of bit, nibble, byte, word and parity bit, definition of digital system. It deals only with two values 0 and 1. It cannot have any other values other than these two. Definition of a bit. Bit means binary digit. It is the smallest unit of data. Its value can be either 0 or 1. The value of a bit is usually stored as either above or below a designated level of electric charge in a single capacitor within a memory device. Definition of a nibble. Group of 4 bits is called a nibble. Since byte is 8-bit long, nibble will be a half byte. Example 0, 0, 1, 1, 1, 0, 1, 0, etc. 4-bit computers use nibbles as their fundamental unit to store data. They were used in early microprocessors, pocket calculators and pocket computers. Definition of a byte. Group of 8 bits is called a byte. In computer systems, byte is used to represent a character such as letter, number, symbol. For example, G5 question mark. Examples for byte are 0, 1, 1, 0, 0, 1, 1, 1, 4 zeros, 4 ones, etc. Example for application of byte is the stream of bits can form a visual image or it can form the machine code of a computer program. Computer storage is usually measured in multiples of bytes. Example 820 MB hard drive. We shall move on to the definition of word. Group of bits is called a word. Example 16-bit word, 32-bit word, etc. Since byte is of 8 bits, 16-bit word contains 2 bytes and 32-bit word contains 4 bytes. Majority of the registers in a processor are usually word-sized, and the largest piece of data that can be transferred to and fro from the working memory in a single operation is a word in many architectures. Next is the parity bit. It is also called as check bit. It is of 1 bit length and it is added at the end of the binary data. It is used for error detection. For example, in communication systems, when we transmit data, there is a possibility that the data sent may be corrupted by the noise in the communication channel, and hence the received data may be different from the original data sent. Hence, we need to detect the error and correct the error. This error detection is performed by this parity bit. Types of parity bit. We have two types of parity. One is even parity and the other is odd parity. Coming to even parity. Here, the addition of parity bit should make the number of ones to be even. So, if the data contains even number of ones, then parity bit added should be 0, because the data already contains even number of ones. For example, consider the 8-bit data as 10101010. Here we can see that the number of ones in the above data is 4. That is, if we set parity bit as 1, then number of ones becomes 5, which is an odd number. Therefore, to retain even number of ones, we must set parity bit as 0. We shall see another case where the data contains odd number of ones. For example, let the data be 11101010. Here the data contains 5 number of ones, which is an odd number. So, to make it even parity, we must set parity bit as 1 so that the data contains 6 number of ones, which is an even number. Next is the odd parity. Here, the addition of parity bit should make the number of ones to be odd. If the data contains even number of ones, then parity bit should be 1 to make it odd parity. For example, consider the 8-bit data as 10101010. This data contains 4 number of ones, which is even. Hence, we must set the value of parity bit as 1. If the data contains odd number of ones, then parity bit added should be 0 to retain the odd parity. For example, consider the 8-bit data as 111010. This data contains 5 number of ones, which is odd. Hence, we must set the value of parity bit as 0 to make odd parity. In the table shown, the first column shows 7-bit data, second column shows number of ones in the data, third column shows the 8-bit data after including the parity bit both for even parity as well as odd parity. In the first case, for the data 00000000, which is 7 bits, number of ones is 0. For even parity, parity bit will be 0. Hence, the 8-bit data becomes 0, 0, 0, 0, 0, 0, 0, 0. For odd parity, since the number of ones in 7-bit data is 0, parity bit becomes 1 and the 8-bit data becomes 1, 0, 0, 0, 0, 0, 0, 0. Similarly, in the second case, for the data 1, 0, 1, 0, 0, 0, 1, number of ones is 3. For even parity, parity bit will be 1. Hence, 8-bit data will be 1, 1, 0, 1, 0, 0, 0, 1. For odd parity, since the number of ones in 7-bit data is 3, parity bit becomes 0 and the 8-bit data becomes 0, 1, 0, 1, 0, 0, 0, 1. In the third case, for the data 1, 1, 0, 1, 0, 0, 1, number of ones is 4. For even parity, parity bit is 0. Hence, 8-bit data will be 0, 1, 1, 0, 1, 0, 0, 1. For odd parity, since the number of ones is 4, parity bit becomes 1 and the 8-bit data becomes 1, 1, 1, 0, 1, 0, 0, 1. In the last case, for the data 1, 1, 1, 1, 1, 1, 1, number of ones is 7. For even parity, parity bit is 1. Hence, 8-bit data will be all ones. For odd parity, since the number of ones is 7, parity bit becomes 0 and 8-bit data will be 0, 1, 1, 1, 1, 1, 1, 1. We shall see how the parity bit is used to detect the single bit error in a communication channel. Let me take Alice is speaking to and Bob is hearing. The voice signal, which is analog, is converted into digital signal and then sent on the communication channel. Let the message be 1001, which is 4-bit. We have to add a parity bit to this data and send it over the communication channel. For even parity, parity bit will be 0 since number of ones in the data is even. Data sent is 10010. Before data transmission, sending end and receiving end should know whether they are using even parity or odd parity. At the receiving end, for even parity, if the Bob receives the data as 10010, he calculates the parity of the data. Here, parity is even, and since we have assumed even parity, Bob considers the received data is correct. Next, we shall check for odd parity. Let the data be 1001. Parity bit will be 1 since the number of ones in the data is 0. So, the data to be transmitted becomes 10011. At the receiving end, if the Bob receives the data as 10011, he checks for odd parity. And since the number of ones he considers that number of ones is odd, he considers that received data is correct. We shall next look for the case of transmission error. Alice wants to transmit 1001. Parity bit value will be 0 for even parity. He sends 10010. Let me consider the second bit 0 changes to 1 in the communication channel. At the receiving end, when Bob receives this data 11010, when he calculates the parity bit, it comes out to be 1. Since they have assumed even parity for transmission, Bob reports the received data is not correct. If Alice sends the 8-bit data as 10010 and parity bit gets changed during the transmission, Bob receives it as 10011. He calculates the parity. He sees that it has odd parity, hence reports that received data is wrong. Let us see the limitations of parity bit. It can only detect odd number of bit errors. If even number of bits change, then it cannot recognize that data received is incorrect. It assumes that data received is correct. Let me take this condition. Alice wants to send 1001. He adds parity bit as 0 for even parity. He sends the data as 10010. I will change the 2 bits in the data. Let the data received be 11011. When Bob calculates for parity, he sees that it is even parity and assumes the data received is correct, but actually data received is incorrect. Coming to multiple choice questions. First one, which is typically the longest? Bit, byte, nibble, word. Options: A. Bit, B. Byte, C. Nibble, D. Word. What's the answer? Bit is of 1 bit, byte is of 8 bits, nibble is 4 bits, word is 16 bit. So answer is B. Byte. Second one, a group of 4 bits is known as A. Bit, B. Byte, C. Nibble, D. Word. Answer is group of 4 bits. So answer is C. Nibble. Third one, the quantity of double word is dash bits. A. 16, B. 32, C. 4, D. 8. What's the answer? Word is usually 16-bit, that is 2 byte length. So double word will be 32 bits. Therefore answer is B, 32. Fourth question. How many bytes are there in 10 111 00 10 110 111 number? Option A 1, B 2, C 4, D 8. You have to convert the data into bytes. So what is the answer? B, 2 bytes, because the binary data given is 16 bits. Question number 5. A half byte is option A bug, B nibble, C octet, D bit. Half byte means 4 bits. So answer is B, nibble. Next, sixth question. The string of 8 bits is known as nibble, byte, octet, quad. Answer is B or C, byte or octet. Next question. One nibble contains the number of bits equal to A 2, B 4, C 8, D 16. Answer is B, nibble, because it is of 4 bits. Question 8. Parity check bit coding is used for A, error correction, B, error detection, C, both A and B, D, none of the above. What's the answer? The parity bit only checks for the error and does not perform any error correction. So the answer is B, error detection. Next, the parameter through which 16 distinct values can be represented is known as A, bit, B, byte, C, word, D, nibble. Distinct values. So answer is C, word. Tenth one. In even parity, the added parity bit will make the total number of ones in data as A, even, B, odd, C, 0, D, none of the above. Answer is A, even. This is the assignment question. List the other methods of error detection and error correction other than parity bit with its limitations. These are the resource persons who have contributed for the development of LMS for the subject Digital Electronics. Thank you.